Good morning all. As just been said, my name is Stephen Williams, Moulder Montage Lightspeed Lift Solutions. I actually have my colleague Johan Sevenants, who is actually a technical manager for Moulder Montage and Lightspeed Lift Solutions. We're actually here to talk about the optic technology which has been introduced to help entrapment issues that are becoming ever more apparent with the issues of side-to-step, also with step-to-step, the cone plates, and also with lift doors. This optic technology is widely used within the automotive industry, especially on buses. It's to help indicate to the bus driver when the entrance and exit doors are at a particular level with the relevant pavements. This allows for easy access for the passenger. Johan Sevenants took this technology in 2009, came to the conclusion that it could be used firstly for help with entrapment issues of to help with entrapment issues for side of step, skirt panel, the step-to-step, cone plate, and lift doors. Now, with regards to the issues that have become apparent with the side of step, as we know, there's always issues of people riding the steps, especially children who sit on the steps, becomes an issue. The systems then advanced further to help with the step-to-step entrapment, the cone plate issues, which often cause considerable damage to the step band, not only to the cone plates. The most recent move forward with the development of the optic technology has been for the lift door entrapments. I'd now like to discuss with you the system of actually the optical detection and how it functions. Now, I've tried to be as brief as possible. There's a lot of involvement with the light signal itself. But the principal operation of the optical detection is microspectrometry. This is the measurement of a change in the light spectrum. Light is a clear signal, as we know, and it can be measured very accurately and reliably with advanced electronics. The closed system of the optic technology is made up of a plastic optical cable. As you can see there in the first slide, that is the optical cable, and as you can see, the light signal actually coming out of the optical cable itself. This is advanced to an electronic module, and use is made of this system involving the entire spectrum of the light. It's coupled into the optical cable, and through the software, various colors which are put apart are assigned to these base values. These base values, as well as the desired bandwidth, are stored in the core of the system and form the limits of the detection. And when pressure is put upon the cable provided by mechanical breakpoints, sensor points, for the distortions in the cable change the spectral light distribution. Including these new values belong the set limits of the detection a signal will be given. When this preset distortion point has been reached, it can be as sensitive as 0.01 millimeter of movement. A signal will be given to the module unit to immediately stop the machine at its safety function. The kink points caused in the mechanical light changes at the application of pressure using the predetermined sensor points finally provide for the detection. Changes in the composition of the light, such as dirt, moisture, temperature, do not have any significant influence on the operation of the system. The various parameters of this system to adapt by its application, they're tailor-made, making unique multiple detection possibilities. This makes the system intelligent that can have the function to carry out auto-calibration The system for the auto-calibration functions that if an object's become trapped, for instance at the cone bearer, and it hasn't been removed, shall we say, for 10 seconds, the system will auto-calibrate to this new position. This will allow for safety to be reinstated automatically. The system is pressure sensitive. It's force over time, which measures at 240 times a second, so is not susceptible to impact blows to trigger the distortion. This accuracy of this system has a wide range from 0.1 newtons to 10 tons. So as you can see, it's very accurate. As we know, especially with escalators, there are many incidents where passengers misuse the machine. I'd now like to discuss with you the actual entrapment points themselves. Beginning with side of step skirt panel, which has been for many years a major incident issue, especially involving clothing, shoes, and especially children who sit on the steps. Only recently, this year, there was a small boy who was riding the steps in this manner, sitting on the steps, had his hands to the side. The actual hand became trapped in the side of step, the skirt panel. Luckily, not a major issue, obviously damage to his hand, but obviously could have been a lot worse. The sensor points of the system, they're mounted at the strategic points behind the skirt panel, at the center point between the fixing brackets. This is where the most distortion takes place, and as we've already discussed, with the system being pressure sensitive, the skirt panels can be kicked, which quite often happens. The system understands that there is no pressure being applied, so will not cause any unnecessary downtime due to being kicked. So no impact blow will activate the system. The next aspect I'd like to talk about is the cone plate detection. This optical system, it's mounted just in front of the cone plates on the cone bearer behind the skirt panels. Now it's mounted in this manner so as not to interfere with the existing safety switches. It works alongside the existing safety switches as an extra preventative. Has the added function of being able to detect vertically and horizontally. As we know with most manufacturers, their cone bearer system will only function in one direction. So with this system being applied, it has the added security. Often the case, especially with the cone bearer, that passengers will jump from the lower transition point, especially on down-running machines. They'll jump onto the cone bearer, and obviously this can cause issues where the cone plates actually depress into the step treads of the escalator. Now with this system being pressure sensitive, it won't activate. If the current existing safety switches will activate, that's obviously out of anybody's control, but the actual system of the optic detection will not activate. But with the fact of being the pressure sensitivity, if any foreign objects become trapped within the cone plates, shall we say a screw, as that screw enters the gap between the teeth of the cone, as that pressure point has been reached, the system will detect and shut down. Now, as we know with screws, if that screw has become embedded, it will damage the whole step band. So instead, with the system of the optic detection, instead of having the whole step band scored, you'll only have in a certain number of steps. This obviously helps reduce damage to the machine, expensive costs to repair, replace the steps. Excuse me, there was one other aspect. With the cone bearing incidents of entrapment, there was a big fatalities recently within Canada and Belgium, which were of strangulation. Now, these were very unfortunate, but they may have been avoided using the optic detection system. Now, as we know, with this sort of entrapment issues, they're usually caused by loose clothing, long dresses, scarves, and most common of all, footwear. As you can see there, and as has previously been indicated, flip-flops. Also soft-soled shoes, Crocs, Wellington boots. The actual soft sole of the tread of the footwear becomes embedded into the step tread. And as we know, especially if you have various people riding the escalator, one person will turn around, talk to their friends, not paying attention to the exit of the machine, with the soft sole depressed into the step tread. And as you can see by the picture, the teeth of the combs will actually grab, not only causing obviously damage to the machine, but obviously damage to the individual as well. I'd like to discuss with you now about the lift doors, especially the center opening lift doors in itself. Now, as we know, especially with scenic lifts, with the glass panels, they're like a viewing area for especially children. Love to see the mechanics of the lift going up and down. Now, as you can see with the depictions of the children, they're resting their hands on the glass. Now, when the lift car arrives, the landing doors will open. The hands, they follow the door, sort of have a reason. They, obviously children have a different understanding. They don't remove the hands. Now, there is that entrapment point, especially with the small fingers and small hands, between the lift door and then the door frame. There is a preventative system to work alongside the corrective system, that as the pressure is being put onto the lift doors, the system has an understanding to prevent. Very simple solution, works alongside the corrective, which if the preventative were to fail, there is the backup of the corrective system. Now, with regards to all that we've discussed with the entrapment points, the actual lift door-to-door frame, the side of step skirt panels, the comb bearer, comb plates, may all be well within their manufacturer's recommended tolerances. But unfortunately, with moving parts, there is always a possibility for entrapment. Now, unfortunately, as such, this can prove to be expensive litigation costs for damage to the individual. Then, of course, you've got the downtime to the units. You've then got expensive repair costs. Now, it can always be said for all the issues that we've covered today. Thank you for your time.